Uh, Hello, welcome back to the continuing lecture in time value of money. Uh, this is Dr. Jeff Holm, and we are now looking at an Excel file. And once again, just for your information, all of these files that we are using for the class are located in the each respective topics folder, right? The first, um, in the course materials folder, um, most likely the first two files on the top, two or three files on the top in each folder, if you go into each topic, uh, the first couple of files on top, those are the the files that we use for the class. Okay, so you can download this file, which is titled time value, right? Uh, and it's an Excel file. And there's also a PDF file of the slides that I'm using. So don't just watch the video, and that's not the end of it. You should be exactly you should exactly emulate what I'm doing, what I'm demonstrating in the video. Okay, you understand? Um, and sometimes uh, you might find solution cells already filled in. But if that's the case, then you can just simply clear it out, delete those cells, and then uh, just uh, follow and uh, follow my demonstration. Okay. Uh, I mean, if you while you may not be able to do it while watching simultaneously, right? But then after watching the video, try it on your own, or you can replay the video and uh, put it to a pause while you right. It's just self-explanatory, right? If you want to um, uh, follow my demonstration, you'll just need to pause the video and just catch up, right? All right. So now this is the setup of the example we used in the last class, in the last video. First of all, let's take a look at the labels, right? P, of course, stands for principal. APR, of course, annual interest rate. Time in years. Now, M is the compounding frequency, right? Of course, that's future value. So our last example was like this. Principal was 1,000, 6% APR, 5 years, and compounding is annual. And in that case, you simply the future value is equal to future value equals, right? This is exactly uh, what it is. Logically, this is the cell where future value must go in, right? But then how do you find future value? Well, if you exactly build the formula into this cell. So literally, future value is equal to, then principal, this is the principal, right? You just click it in, right? You think some people are typing in A3. No, don't do that. That is, I didn't type it in, right? What did I do? I clicked it in using the mouse. I clicked it in. Okay, because if I manually type it in, you would see A would appear first, and 3 will appear after that. But that's not what happened. A3 appeared simultaneously, right? It wasn't two strokes, it was just one stroke. So what does that mean? I didn't type it in, right? So I just clicked it in, and then because I'm doing exactly reproducing the formula, right? Because that's the principle, right? And then times, open parenthesis, 1 plus r, right, raised to APR, right? That I we talked about this at the beginning of the semester, right? This is called caret, right? Which is a universal machine language for raising something to power, right? So raised to 5, okay? And hit enter, right? And there you go. So actually, uh, the benefit of, you might think, can I do it just, uh, on, paper, with pencil? Yeah, yes, you can do it that way, but the benefit of using Excel is if you have multiple problems of the same pattern, right? If you have multiple problems of same pattern, you can do, for example, if I have the problems like this, over and over, right? A dozen of them. All I don't have to, if you use, pencil and paper, then you'll have to do every problem, one by one, all over again. Each problem, the next problem, it's a new problem. You have to solve it all over again. It just takes a lot of time. It's not uh, in this day and age. You don't, well, you need to be efficient, right? Time, the old adage, time is money, is not it's not 21st century concept. It is a very, very, very old concept, right? Whatever saves time, but it's not like you're. But I'm gonna get to that later. But you may have noticed that once I found this, then this cell automatically populated. How? Well, it's simple. I just made it equal to this, right? So uh, once I got this, then automatically this will be filled in. Logically, think about it. If this is made to be equal to this, then it's going to automatically reflect whatever is here. Now, so that wasn't that bad. I mean, that wasn't, that is very basic, compounding formula. It's not that difficult. Now, what about if compounding frequency is 4, in other words, quarterly? Then we'll have to make adjustment, right? We've done, you've seen this in the previous video. So all you need to do is simply once again, principal times 1 plus, right, APR, and you divide it by compounding frequency, right? And then raise it to t times m. Okay, and then make sure you have parentheses, right, around the t times m, because without parentheses, what's going to happen? If you don't put parentheses, uh, what will happen is that if there is no parentheses, uh, what's going to happen is um, the formula is just linear, written linearly. The formula is written linearly, so Excel will execute it linearly. So this will be done first, right? And of course, first of all, whatever is in the parentheses will be done first, right? Of course, this will be done first, right? Because it's always, PEMDAS, right? Uh, uh, Division will be done before addition, right? And then it will be multiplied, right? And then what's going to happen? It will be raised to power. It will be raised to power. And then will be multiplied by d2. So then that's not right. That's not that you c2 times d2. In other words, t times m is the n that this term should be raised to, right? So you must make sure that you put it in parentheses. And once you do that, what's going to happen? Yes, this is the future value with when compounding frequency is quarterly. Now, and what do you notice? Oh, it's the same, basically same input data, right? Same principle, same APR, same 5 years, but different results. Of course, you get greater future value, right, with higher compounding frequency, right? It's not that much greater, but at least, between this and this, which one would you prefer? Of course, nobody will prefer this. Nobody in their right mind will prefer this, right? The bigger the future value, the better it is, right? And the reason, so this gives you a new realization. Although all the input data are the same, right? The higher the compounding frequency, right? Uh, the higher the future value, right? Because more compounding, right? More frequent compounding results in greater final result. Okay, and also, but that the difference cannot be, the difference will be, of course, it's difference is, discernible. In other words, you can tell the difference easily, but it won't be this, it won't be outrageously different. For example, you can also tell whether uh, you have to use your own judgment, critical thinking, right? Uh, you cannot just leave it to the formula, right? Because if you made a mistake like this, right, previously, if you make a mistake like this, how do you know you got it wrong? Look, this is your critical thinking. While the compounding frequency may be different, but that difference cannot result in this much, outrageous difference, right? This is exorbitantly different, right? You're starting from 10,000, same 10,000 principal, same APR, same 5 years. Just, difference in compounding frequency cannot result in this much difference, right? And anybody who has, who can think, right? Anybody who has, that's critical thinking, right? But that's, in the old days, they just called it thinking. People who could think, well, will question this, right? You won't just, walk by, right? But once again, all these things, when you're younger, when you're young, your brain isn't, at this level. I mean, you just, oh, I just did whatever, the professor taught me, so it must be right. But, when you didn't do it right, right? Because uh, if you missed the parenthesis here, then you didn't do it right. But how can you check? You have to have that uh, you'll have to have that mindset, right? You cannot just walk away. Well, you have to make sure. You'll have to check whether you got it right or wrong. And before looking into the formula, you can already tell something's not right. If there's such an excessive difference, such an outrageously huge difference, then something's wrong, right? And this is critical thinking. And when you're young, you are more likely to just to walk away, right? It's Excel, so it must have, uh, it's what Excel did, so it must be right. No, it's what you did. You didn't, right? Excel only, Excel only, executes the Excel only executes the command you gave it, right? And if you give it the wrong command, it will just execute the wrong command, right? So it's finally, I mean, it falls upon you, right, to make sure Excel carries out the right command. Now, another thing is here, I told you before, you know how to copy and paste. Now, if you did this first, you can simply copy and, paste it down, right? But then well, why do we need to do that? I mean, is there anything different? Isn't that the same thing? Of course, on the surface, it's the same number, right? Of course, how can it be different? But in the structure, look into the, deep structure. I wouldn't. this is the term I borrowed from Noam Chomsky from his uh, linguistics. Deep structure. In other words, if you look into the formula, right? Uh, the formula has, changed. I mean, it's the same formula, but previously, I used this, right? But this time, I'm using this because I copied and pasted this formula. But then what is the difference? Um, there's no difference. I mean, in this case, but the only thing is that I divided it by m and multiplied it by m here. But then, m is 1, so it doesn't make any difference, right? M is 1, right? And doesn't make any difference, right? Because 1 doesn't change anything. But then why do we do it this way? No, first, we have uniform format, right? It's consistent, uniform structure is very important because it can be replicated over and over and over. For example, let me insert a couple of more columns and let me all Okay, not dollars. Okay, and then let's say I have a couple of more problems like this, and each time, right, compounding frequency is different. What else can it be? Quarterly, monthly, daily. What else? Two semi-annually, right? So I have different scenarios, right? I mean, with the same input data, the scenarios are each time the compounding frequency is different. And how do you you don't have to solve everything one by one. All you need to do is simply copy and paste the formula, right? And then automatically, it's the same formula, but it adapts to new compounding frequencies automatically, right? So think about it. When you are dealing with massive problems, massive number of problems, right? It really it makes it a lot easier, right? And it's not like you are copying somebody else's work. You have done your work already. You're just replicating your own work. You're just copying your own work. So there is nothing. What did I do? There's nothing. You have proven that you can do this, right? So you don't need to prove it again, because you have already proven it. So you don't need to do it all over again. You can just simply copy and paste it, and then you can handle massive problems, right? And let's sort this. Let me sort this, right? Because this is in oh, no. Why is it doing this? Why is it? Only sort this. Okay, let me do this. Where was that? Filter. Okay, and then sort by. Oh, I see. The reason this is happening is because if I sort it, then because of this equal signs, so let me. So let's see if I do it like this. Well, So then if you sort it in ascending order, right, then you can see in, just one single view, right, the higher the compounding frequency, right, the greater the future value, right? Now, let's take a look at row 9, right? And in the original file, right, I had only 2 rows and I inserted more rows. So you may try this later. It's the same setup, 5 years, right? And just, annual compounding. But what I have two more columns. So, and these additional columns have labels like periodic R and N. So what does that mean? Well, that means I want to put R, periodic rate, and N there. So we already know what periodic rate is. It's 6% divided by 1, and 5 times 1. If it is annual, it's going to be like the same thing. There's no difference. But if it is, let's say quarterly, then you see the periodic rate automatically adjusts and automatically adjusts. And now all you need to do is simply apply this formula. So P times, future value is P times 1 plus R, not this one, because the periodic rate is already found. So all you need to do is simply then raise that to N and check it, right? Check if this is the same thing as this. Yes, of course, right? This is when the compounding is quarterly. So what's the difference here? There isn't. The only difference is that here I didn't make adjustment, right? I mean, in this case, I made adjustment to APR and T, right? In other words, eventually APR divided by M is what? That's R, periodic rate. And T times M is what? That's N. But I made that adjustment inside the formula, right? But here, I made that adjustment outside the formula, right? I made that adjustment outside the formula. Then, what's the benefit of that? The formula can be simpler, right? Now, there's another benefit that comes with the simplicity. Now, these are still very simple formulas, but if the formulas get more and more complicated, if you make any mistake in the formula, then it's going to be difficult, or it's going to take more time to locate and identify the source of the error. In other words, it will take more time to fix it. But if the formula is simple or simpler, right, it's easy to identify the source of the error, right? And then you can fix it easily, right? And besides, think about it, if the arrow was made here, right? Let's say instead of doing like this, you should have divided by that, but accidentally you click this accidentally. Then it comes to this, and this is already just by simple mentally you can check, oh, what's wrong? I mean, is 6% divided by 4? Is that 1.2%? Can it be? And something, using your critical thinking, you can, so where did I go wrong? You look into it. It's easier to find rather than finding it from here, right? Rather than finding it, if it was like, here, if the problem was here, right? It would be more difficult to find the source of the problem. But if it is like this, it would be easy to find, oh, right? I made a mistake here. So then you can fix it easily. And once you fix it, then, right, it's going to be automatically taken care of. All right, so that's it for this video, this segment of the video. I will see you in the next video. All right, thank you for watching. Stop.